Reference angles. Example 3 of day 1 of the unit circle supplement notes. We've already covered in clip 1 being able to sketch an angle on the coordinate plane, both positive and negative angles. In clip 2 being able to find coterminal angles. And now in clip 3 we're going to be able to find the reference angle of a given angle. Well, if you noticed, and you may not have, but some of you did, when we were drawing points and writing ratios for sine, cosine, and tangent, we had to have right triangles. So if I gave you a point in quadrant 1, you had to have the angle we were talking about was at 0, 0, and you dropped a line down from that point to create the right triangle. Whereas if I had a ray in quadrant 2, or a point in quadrant 2, then I dropped the line down, creating my right triangle. Now we had that right triangle. Well, this angle right here isn't really the angle for this ray. The angle for this ray starts at the terminal side and goes here. It goes all the way to here. So that's the actual angle, but that's an obtuse angle. And we can't use sine, cosine, and tangent for obtuse triangles. If we're trying to solve obtuse triangles, we have to solve right triangles only. So we use this as the reference angle when the actual angle, we'll call it A, is actually from here to here. Some of you might want to see some number examples, but some of you already know how, ignore the blue part, this pink angle here and the green angle there are related. You might have guessed it, yes, they're a linear pair. So there's going to be an easy way to calculate the value of this angle if we know this angle, because they form a linear pair. Then we'll have something a little different, but the same idea in quadrant 3. In quadrant 3, if you have a point, the angle actually starts all the way back here at 0 degrees and rotates all the way around. That's even bigger than 180 degrees. So we drop and make a right triangle and use this as our reference angle. And if you're in quadrant 4, well, then you really have problems because now it's more than 270 degrees, right? And you can't use that to solve a right triangle. So we drop this line and we use this as our reference angle. So 4 possibilities. The reference angle in the first quadrant always creates a right triangle no matter what. So the reference angle is the angle. We have 3 other places that the terminal ray could happen, and we have to create a reference angle to be able to solve using SOHCAHTOA. So that's the idea behind why are we doing reference angles to begin with. Reference angles. A reference angle is a positive acute angle measure from the terminal side of a ray to the x-axis, represented by theta prime. I wrote it as theta, but it will be theta prime. So let's practice just drawing this, because eventually we're going to have to solve trigonometric ratios using it. So 137 degrees, we know that that's more than 90 and less than 180. So I'm going to, in blue, draw a sketch of that angle. And I'm going to call that angle theta. From here to here is theta, and theta is 137 degrees roughly. It's supposed to be exactly, but that's what we're saying, is that is 137 degrees. Well, I need to drop a line from this terminal ray to the x-axis, creating my right triangle in pink. Inside that right triangle is not 137 degrees. It's an acute angle at the same vertex, this angle, which we call theta prime. So you just put a prime on it, just like we did when we were doing transformations with images and pre-images. So think about this as the pre-image angle, and this is the pre-image, and this is the image angle, but not really. This is actually theta, and this is its reference angle. So we know that these two form a linear pair. If it's in quadrant 2, it forms a linear pair with quadrant 1. So all I have to do to find theta prime is 180 degrees minus theta. So 180 degrees, because these two add to 180, 180 degrees minus 137, 180 minus 137 is 43 degrees. So if I'm going to do anything in this triangle or solve this, if I actually knew lengths for this and wanted to find the other stuff, I'd be using a 43 degree angle and SOHCAHTOA to find the other side lengths. negative 250 degrees. Negative 250 degrees, we know from our quadrants that we have negative 270 goes down the negative x-axis. So negative 250 has to be like over here somewhere. There's my negative 270. That might be a little hard to see because of the pencil. So I'll trace over it in blue. There's my negative 270 degrees. But I can't use negative 270 degrees because when I'm making a right triangle to solve it, I drop a line or bring up a line to the x-axis. There's my triangle. Right here is theta prime. Right there is theta prime. It has the same vertex, but it's not all of 270, right? In fact, it's only this piece of that whole thing. So if you look carefully though, right here to here, everybody knows from here to here, we know how much that's worth. All I want to know is how much this little piece of the whole angle is worth. Well, you might have guessed it. If the angle is in quadrant 3, then we just have to take theta, our negative 270, well, I did 270 instead of negative, and I wrote negative 270. This is negative 250, or this is positive 250. Please change it. We'll do negative 250 in a second so you have an example of a negative. Positive 250, sorry. Moving too fast and trying to think ahead of what I'm going to do next for you. So we've got positive 250 here. This whole thing is 180 degrees, and I don't know this piece. So if I do theta minus 180, then I will get theta prime. Theta prime equals theta minus 180. So if I do 250 minus 180 degrees, 250 minus 180 degrees, I get 70 degrees. Theta prime for this is 70, because 70 plus 180 will give us the 250. Now that's for the positive angle. We'll do one more positive and then I will give you the negative. I want you to see at least one more positive before I do the negative for you. For letter C, we have a 330 degree angle. We know that this is the positive x-axis. So I have 90, 180, 270. I don't want to go all the way to 360. I want to go to 330. So I've gone all the way around here. That's theta. That's 330 degrees. I can't use that. I have to draw a line up to the x-axis to make a right triangle, and I have to figure out what the heck theta prime is. If you look at this angle, because it's in quadrant 4, it almost went full circle, but it didn't. The amount that it didn't go full circle is the amount I need for theta prime. So if you think about it that way, theta prime, when it's in quadrant 4, has to be a whole circle minus this. Full circle is 360 degrees. Take away the 330. That means theta prime has to be 30 degrees in order for that to complete the circle. It would take 30 degrees for this ray to spin back up and do a full revolution. So now that's in quadrant 4, dealing with positive reference angles. So with positive angles, we can find the reference angle pretty easily just using linear pairs if we're in quadrant 2, taking away the 180 degree angle if we're in quadrant 3, and taking the angle away from 360 to figure out what's left when we're in quadrant 4. We'll summarize all of that in a second. For now, I would like you to try letters D and F. Pause the video and try D and F, and then I will give you an example of a negative angle. All right, welcome back. Here's letter D. I've sketched the 95 degree angle. In order to create and solve a right triangle, which we don't have any more information to solve right now, we have to drop a line to the x-axis. So we're really trying to find theta prime, the angle inside that triangle at the same vertex as 0, 0. Well, these two, this is in quadrant 2. Remember, in quadrant 2, these two angles make a linear pair. So 180 minus 95 gives us 85 degrees. 85 degrees for theta prime for letter D. For letter F, we have a 190 degree angle. 190 degree angle, but we can't use that in a right triangle. In a right triangle, the other two angles have to be acute. So we need to find the reference angle if we create this right triangle by going up to the x-axis from our terminal ray. Well, this is a full 180 degrees and I'm in quadrant 3. So in quadrant 3, I'm going to take my original angle and subtract 180 from it to get 10 degrees for my reference angle. 10 degrees. Hopefully you got those right. If you did, please try letter H. If you did not, please go back and review how to find reference angles as we listed them above for quadrants 2, 3, and 4. Please try letter H, and then we're going to talk about negative angles. Hopefully we're back very quickly. I don't think I even paused the video, but 20 degrees or 25 degrees is in quadrant 1, and in quadrant 1 we just drop an angle down and the angle's already acute. This angle is already acute. So theta prime is theta. I don't need a reference angle when I have an acute angle at the vertex of 0, 0 in quadrant 1. No need for a reference angle. The reference angle is the angle itself. 25 degrees. All right, so going on to those pesky negative angles. Here's what we're looking at, a negative 75 degree angle. We can draw a sketch of that. That's not bad. The problem comes into solving the negative, but it's not as bad as you might think. So we know here's negative 90, which means negative 75 is in quadrant 4 somewhere, and I'm just going to draw a little sketch right there. It's not perfect, but it's good. So there's my initial and my terminal ray, and this goes down negative 75 degrees. Well, I don't want that. What I actually want is just this angle, but it has to be positive, because if I'm solving a right triangle, yeah, we can have sides negative because they're representing that we've gone left or down, but we can't have the hypotenuse negative, and we can't have negative angles when we're doing SOHCAHTOA. So what I need here, well, actually, we'll talk about that for when we're doing the inverse, but right now we're not there. What I need here is to find a coterminal. So for all negative angles, find a positive coterminal, and even for angles that are bigger, between 0 degrees and 360 degrees. So if you have an angle that's 400 degrees, for negative angles, I would say, and for angles greater than 180. Angles greater, not 180, greater than 360 degrees. So if I had a 370 degree angle, I would have to find its coterminal angle before I could start doing what we've just done with quadrants 2, 3, and 4 to find the reference angle. So you need to make sure you have a positive coterminal angle, between 0 degrees and 360 degrees before you can even begin finding the reference angle. So you must first find a positive coterminal between 0 and 360 when we're working in degrees. First, find a positive coterminal between 0 and 360. If you don't do that, you're going to be lost. It's going to be stumping you. So, oh, I just threw that picture away. Here we go. So we have this picture of this 75 degree angle.
Teachers, please begin your third presentation. Thank you.
We are going to find a coterminal. Well, I could go the other direction to get my coterminal. In fact, I would do negative 75 plus 360, or 360 minus 75, and I get 285 degrees. The cool thing about when the negative angle is in here, you're about to see in a second. So I've got this right triangle. I want to know how many degrees that is. Well, it's pretty obvious because it's an acute angle. But here's the idea. It's in quadrant 4, right? Here's my quadrant 4 angle, 285. It's almost gone, full circle. So if I do 360 minus 285, I get 75 degrees. So The cool thing is when it's in quadrant 4 and it's in a negative acute angle that's in quadrant 4, I'm just going to change the sign on it. Yeah, because it's the same as if I found a positive coterminal and then took it away from 360, I get the same thing, only as a positive angle. So the theta prime is positive 75 degrees. That's not going to work for all of them. Let's take a look at letter G. Letter G does not work that way. In letter G, I start at 0, or start on the positive x-axis, and I have to go a negative 300. So I have to go all the way around clockwise past 290 to get my negative 300 degree angle. But that's not so bad because I'm not going to really have to worry about finding a reference angle in a second because it's in quadrant 1. What's nice about that is if I know this, if I find a coterminal, it'll already be an acute angle in that quadrant. So if I do negative 300 plus 360, I'm going to get that this is 60 degrees because that's what would make it go around, right? That additional negative 60 degrees would make it go 360 degrees around. So there is my reference angle. Just in finding the coterminal, I have it. Not always going to happen. And the case where that doesn't always happen is here at letter I. Here's letter I. We have our quadrants. We have an angle, or our initial ray. We've gone negative 137, so past negative 90 into quadrant 3. This is negative 137. When I drop my line up, I'm in quadrant 3. So I'm going to have to use some things to get my reference angle. Here's theta prime. But first, I need to find a coterminal angle. The coterminal angle going in the positive direction. To get there, in the positive direction, if I have 360, if I have negative 137 plus 360, all right, negative 137 plus 360, or I could just do 360 minus 137, I'm going to get 223 degrees. So a coterminal is 223 degrees. Well, that's not acute, so it can't possibly be that angle right there. But now that I've found the coterminal angle, I just have to think, how is that related to this? Well, in this positive angle, they started by going 180 degrees. And now, I just need to know how much further they went to get to 223. So 180 plus theta prime equals 223, or if you follow the rule that we wrote earlier, theta prime is the angle minus 180, then it would be 223 minus 180. 223 minus 180 is 43 degrees. So this angle right here, theta prime for this problem, is 43 degrees. This one was not as convenient. We started out with a negative angle. It wasn't in quadrant, didn't have a terminal ray in quadrant 1 or quadrant 4 like letters E and G. If it ends in quadrant 3 or quadrant 2, we're going to have to first find a coterminal, a positive coterminal between 0 and 360, and then do the rule to find the reference angle. So here's a little chart that you might like to use to summarize what we did and what we talked about with our rules up here as we described how it worked. If you are in quadrant 1, you're going to have lots of things with these quadrants, so you'll know them really well by the end of this unit. Well, even just this section. If you're in quadrant 1, theta prime, your reference angle, that's the reference angle, is theta. They're the same thing. Because you're just sitting right there, there's your angle. I don't need to do anything, it's already acute. If you're in quadrant 2, as we saw in quadrant 2, the two are a linear pair, so I just have to do 180 degrees minus theta when I'm working in degrees. If you're in quadrant 3, like we were for letter B, you can see the terminal rays in quadrant 3, we've already covered 180 degrees plus some. Well, that plus some is what we want for our reference angle. So we do our angle minus 180 degrees to get theta prime. And in quadrant 4, as you saw in letter C, it almost goes full circle when you're in quadrant 4. We just need to know how much more to go full circle. So we do 360 minus the angle. Our reference angle is 360 minus the angle. This chart, memorizing this chart, can help you find reference angles quickly and efficiently. If you know based on the number of degrees that you're in quadrant 1, then your angle is your reference angle as you set up your triangle for SOHCAHTOA. If you're in quadrant 2, then you're going to do 180 degrees minus whatever the angle was to get you there, if it's a positive, given that it's a positive angle or a positive coterminal angle. In quadrant 3, if your terminal array is in quadrant 3, based on the number of degrees, you're going to take that angle and subtract 180 degrees to find that little angle right up there. And if you're in quadrant 4, you're going to do 360 minus the angle you were given to get your butt over to quadrant 4, and that'll give you this reference angle right there. This chart can be very helpful. I would suggest memorizing it. You do not want to waste time on assessments trying to figure out reference angles like we figured them out in A, B, and C. I was trying to do it in a way that would make it make sense to you. But now that we see the rules and see how they work, and if you don't, you can see me in class for help, you want to memorize these rules for quadrants 1, 2, 3, and 4 in finding reference angles. This concludes all 3 video example clips for lesson 1 or day 1 of the unit circle. Have a great day.